Okay, so today we're doing chapter 4.1, and it's called Interpreting the Solution of a Linear Equation. And so what does the solution of a linear equation mean, right? That's what it's saying. So learning goal, by the end of this class, I should be able to solve an equation using table values, graph, and algebraically. So there are three methods you can solve a linear equation: using a table values, a graph, or algebraically. And we'll practice all three today. Okay. So here it is. Here's the definition of basically a solution. And I already told you that what it means in the last chapter. A solution to an equation satisfies what? The equation. Makes the left side equal to the right side. Okay. So the solution is the value that satisfies the equation. What will make left side equals right side? Okay, now let's do this question here, example number 1, and says Luca wants to take a road trip. To rent a car, it costs her $20 plus 50 cents per kilometer she drives. If she only has $100, how many kilometers can she drive? Okay. Okay, so we did this in the last chapter, and so this chapter does deal with what we learned last chapter. So please, you need to go back to last chapter and see if you can improve on some things before we can really excel on this one, right? So, so again, what you can write is your relation. The relationship between the cost and the kilometers equals to what? The cost is equal to what? 20 plus what? 0.5 per kilometer, right? So this is the relationship between the cost and kilometers. And so let's replace all the words with letters. So y is equal to what? 20 plus 0.5. This per kilometer should give you the idea that this is a what? A rate, and the rate always is the slope, right? And the slope is always m, and then goes what? mx, right? So the x needs to be attached to this one because this is a slope. This is the rate, okay? So this, the textbook will call the relation, okay? Now, it does give you more information in this question, and the question here gives you this piece of information. And tell me, what value is that for? What value is that for? Which variable is that for? It is for y, right? This is the cost, right? So this is y equals what? 100. So what did I say? If you know the value of what? The variable, what do you do with it? You plug it in. So what do you get? You get, so we're going to sub in y equals 100. So you get what? 100 equals to 20 plus 0.5x. Okay, and so this, the textbook calls an equation. So this is the equation that we have to solve. We have to solve this one. Now, if I want to solve this, what do I have to do? What did I say? To solve it, it has to what? Satisfy the equation. So what does that mean? I have to find what? Find a value of x to make what? This whole side equal to what? Equal to 100, right? So that's what you're really doing to solve this, okay? When I say solve, you're trying to find the value of x, okay? Find the value of x. To make 20 plus 0.5x equal to what? 100. Okay. What value of x, okay, will give you 100 on that one side? So let's do this using a table value. So we're going to solve this 3 ways. Table values, graphing, and algebraically. What's so small? Okay, so let's go here. So we're going to solve using a table of values. So here we go. X and what? Y. So again, we're looking for what? A value of X to make Y equals what? 100, right? So we can try something like what? 10? Let's say 10. What do you get then? You get 20 plus, okay, 0.5 times 10. And what does that give me? That gives me 0.5 times 10. Move the decimal point over once, so you get 5. So 20 plus 5 is 25. Is that the answer? X equals 10? No, because X equals 10 only gives you what? 25. So we got a much bigger number, right? So let's go 100. Okay, so what do you get? 20 plus 0.5 times what? 100 is equal to what? So 100 times 0.5, you have to move the decimal point twice. So you get what? 50. 50 plus 20 is 70. But did we reach what we wanted? No. So we still have to keep going. So let's try 200. Okay, so this is 20 plus 0.5 times 200. Okay, which equals to what? 120. Oh, what happened now? We went too far, right? So the answer is where? Somewhere in here. So the answer, okay, so the answer is between what? 100 and 200. Somewhere in between you have the answer. So let's try 160. So 20 plus 0.5. 0.5 times what? 160. Remember, 0.5 is what? Half? Yes? Half. 0.5 is half. Half of 160 is what? Half of 160 is what? 80. 80 plus 20 is what? 100. Yay! So that's the answer. What's the answer? What's the solution? X equals 160 is the solution, right? All right. So the solution is X equals 160. Okay. So it means she can drive 160 kilometers or something. Okay. So what we're going to do now is we're going to solve this using a table of values. Okay. So, sorry, table of values we just did. Okay. Do you see how to find the solution here? Right? You try different values of X and you try to get the Y value that we wanted. Now let's try to graph it and see where the solution is on a graph. So if I graph this, where do I find the solution? Okay. Where do I find the solution on a graph? All right, so let's take a look. Yeah, I don't know if you have a graph paper, you can try a graph paper. If not, just try to sketch it as best as you can. So on this side, what do you put? This side is the what? The Y, which is the cost. Okay. And on this side, you put what? The kilometers. Right? Okay. Now, you have this. You have 100 equals to 20 plus 0.5x. Okay. Now, remember, if you want to graph something, you need what? Y equals something, right? You need x and y. However, I don't have x and y here. But remember, I did write the relation. What was the relation? Okay. What was the relation for this? Y is equal to that. Do you understand that? So y is equal to what? 20. Yeah, 20 plus 0.5x. So that's the relation that I need to what? Graph. That's what I'm going to graph, right? And remember this. This is what? Y equals what? Y equals 100, right? We needed that to be y equals 100. Does everyone understand that? Okay, so what I'm going to do is I'm going to graph this and that. I'm going to graph this and that. Okay, so here we go. Where does my line, let's graph this one first and then this one second. So where does that line start? Where does that line start? Hello? Where does this line start? 20, right? So it starts at 20. Okay, here. Now, I have points every 20. So for every 20, okay, what is it? So remember, it's like 0.5 for every what? 1. For every 20 kilometers. Okay, so for every 20 kilometers, how much is it? For every 20 kilometers. Just put 20 here, right? 0.5 of what? 0.5 of 20 gives you what? 10? Okay, so it has to go up every 10. So every 20, it will go up 10. Right? How do you get from 1 to 20? You multiply by what? 20. So if I multiply the top one by 20, I get an equivalent ratio of what? 10 over 20. So it goes up 10 over 20. Does everyone understand that? Yes? Did everyone understand that? The rate is what? 0.5 over 1. That's the slope. Okay, but I'm going to go every 20 here. So I multiply the 1 by the x value by 20. That means I have to multiply the top value by 20 to get what? 10. So it's 10 up, 20 over. Does that make sense? Okay, equivalent ratios. Okay, so 20, right there, 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 there. I'm putting a lot of dots so I can draw it accurately here. Anyway, it looks something like that, yes? And you should use a ruler. All right. So that is my y equals 20 plus 0.5x. Now let's graph y equals 100. You ready? When x equals 0, what does y equal to? 100. When x equals 20, what does y equal to? 100. Okay. When x equals 40, what does y equal to? 100. When x equals 60, what does y equal to? 100. Do you understand? Y is what? 100 no matter what. No matter what x value I choose, y is always going to be what? 100. Does that make sense? So what kind of line is it going to draw? Straight what? This is sort of straight. Mine looks crooked, but this is supposed to be straight too. What kind of line? Yes, this is linear too, but what kind of line is this? What specific word? Horizontal line, right? So it's going to be a horizontal line. Here, let me do it in a different color. Do you see when I graph, okay, when I graph the equations, okay, where is the solution? Where can you find the solution on a graph? Where do you find the solution to on the graph? Where they meet. Yeah, look. Right? La da 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 da. Boom, right there. Ah. Oh, look at that. Can you see that number? What does it say? X is what? 160, you see? Okay, so X is equal to 160. That's the solution to your equation. Is that okay? So how do you solve using a graph? You graph two lines. Okay. You graph the left side and you graph the right side of the equation on the same graph. And your solution is where? Where they meet. Okay. The solution is the point of intersection. The point of intersection is the solution, basically. Okay? And I usually abbreviate as POI. Okay? So the point of intersection is where your solution, your answer is going to lie. Is that okay? All right. So if you have Desmus, graphing is pretty easy, right? But if you don't have Desmus, graphing is a pain because you have to, draw it up. And the table of values is a pain because you're pretty much guessing what values of X you need, right? So those two methods aren't that great, okay? So let me show you here. If you have Desmus, graphing is fine. Watch how it's done. Y equals what? 20 plus 0.5x, okay? And then what else do I type? Y equals, okay, 100. So I can't see it, so I zoom out or whatever. And there it is, where they meet. So there's your answer, 160 and 100. So when x equals 160, which represents what? The kilometers, you get y of 100, which represents what? The cost. Is that okay? So in Desmus, it's nice to do this, right? To solve an equation in Desmus is nice, especially when they get really ugly, right? Like this or something, right? So then there's your solution there, right? Yeah. So when they're really ugly, when the equations get really ugly, it's nice to use Desmus. However, you should know how to do things algebraically. Okay, so that's the next part that we're going to cover. We're going to cover how do you solve this algebraically. Okay. And I hope you did this already somewhat in grade 8 or what other grade. So let's try it here. So here is our equation that we have to solve. 100 is equal to 20 plus 0.5x. Now, what are we solving for? X, right? So we want what? Since we're solving for x, we want, okay? We want to know what x equals to, right? So we want to know what x equals to. Do you understand that? Yes? Notice what I have here is x equals to something. So in order to find the solution here, do you see x equal here? No, right? There's a whole bunch of stuff with x, right? So what I have to do with the whole bunch of stuff? Get rid of it, right? So when I ask you to solve an equation, I am asking you to find the value of x. What value of x will make this equal to what? 100, okay? But I'm also asking you to what? Isolate. Okay? Isolate x. Have x by itself. Because I want x equals to something. Does that make sense? So when I ask you to solve it, I'm looking for the value of x. So I want x equals something. I want x by itself. I want x isolated. Is that good? All right. So what I need to do here, okay, is get rid of this stuff here. Okay. I want x by itself. Is it by itself? No. I have this and this. So what I want to do is I want to get rid of the 20 first here. Okay. And the reason why I get rid of the 21st is because we have to do the lower bed mass order first. You understand? And addition here, you see the 20 and that's addition. Addition is lower in order, so that's the one I want to get rid of first. And then I get rid of the 0.5 because this is a what? Multiplication, which is higher in the order of bed mass. You understand? So I want to get rid of the 20 first. Okay, how do I make 20 disappear? You just take away, right? You take it away. Well, if you take it away, what does that mean? You are what? Subtracting 20. Okay, so if you subtract 20, it's gone, right? 20 minus 20 is what? 0, and that's gone. Does that make sense? However, remember, this is an equation. It's like a balance. You can think of it as a balance. If I take 20 out of here, is it balanced now? No, right? So what do I have to do on the other side so it is balanced? Exactly the same thing, right? If I double this side, I double this side. If I take away this side, I take away on this side. You understand? So I need to take away what on this side? 20 as well. So I take away 20 as well on this side. Does that make sense? Yes? So 100 minus 20 gives you what? 80. Okay? And 20 minus 20 is gone. No more there. 0.5x. How do I get rid of that 0.5? I already taught you how to do it. You divide it by, right? Divide it by 0.5. 0.5. You divide this side by 0.5. So now 0.5 divided by 0.5 is what? 1. So that's gone, right? Because 1x is just what? X, right? So remember 0.5 divided by 0.5 is 1x. Let me write it like that. Okay. And 80 divided by 0.5 is what? Is 160. Okay. And then here, this is like, you can read it backwards, yes? Read it backwards. X equals what? 160. So I'm going to write it backwards. X equals what? 160. Does everyone understand that? Yeah? So look, x is by itself. That's what I want. And look, that's the answer that we had from above. It's 160. You get it? So that's the preferred method, I think. Algebraically is nice, right? No guessing. Okay, no paper to draw on. Okay. So let's continue. All right, so we're gonna solve. So we're gonna solve some here. Let's go A, 5x plus 10 equals to 25. All right, so in this case, again, you have to get rid of the 10. So what did you do? Subtract what? Subtract 10 on this side and then subtract 10 on that side, right? So you got 5x is equal to what? 15. And then how do you get rid of the 5? Divide both sides by 5. Okay, and that gives you 5 divided by 5 is 1. 1x is just x. X equals to 3. Okay. Is that good? All right, let's try another one. Negative 5x minus 10 is equal to 25. So here, I guess I said take it away, so it's like take away is like what? Minus taking away that, which is negative 10. So, but it's the same thing as what? Adding 10, right? So it's the same thing as adding 10 here and what? Adding 10 here, right? So negative negative makes positive, right? Yeah, so if I add 10 to negative 10, I get 0, and that's what I want. Okay, so that's good. Anyway, this is the right answer. Good? Does everyone understand that? Okay. All right, let's try a couple more examples. All right, so very good. So again, it's negative 20 here. So to get rid of a negative 20, you add 20. Add 20 on this side to get negative 30. Divide by 2 and you get negative 15. Okay, so very good. Let's try another one. Actually, let me write it down here. Now, there's a lot of different ways to do this one, but yeah, let's see what you get. All right, so very good. This is one way of doing it, right? Again, you can do exactly as we were doing before. You're dividing by what? A half. Or just one thing though, just you don't want to write the x too low here. Otherwise, it might look like 1 over 2x, which is something totally different, right? But anyways, that x should be beside or on top. Now, if you divide both sides by half, and that's what you get. 22 divided by half is 44. Okay, so you could do it that way. How would you do this if it's a fraction, right? What did I say? Dividing by a fraction is the same thing as what? Multiplying by the reciprocal, right? So it's really 22 times what? 2 over 1. And 22 times 2 is 44. Do you get it? Okay, so if you don't want to use your calculator, this is what you do. You flip the fraction and become multiplication, and that's what you do. Good? Here's another way to do it. Okay, so let me show you a couple ways to do it here. All right, I get rid of the 8 first. Yeah, same thing. So you got a half x equals to 22. Now, in order to get rid of a fraction, okay, notice this is a divided by 2. You're dividing by 2. Let me go up here. You see, when it was 2x, it was 2 times x. What did you do to get rid of the 2? You divide it. So instead of multiplying, you what? Divide it. So guess what here? You're dividing by 2, so guess what you're going to do? You can multiply by what? Multiply by 2. I wrote it in the wrong place. Here. Okay, you're going to multiply that by 2. Okay. Now, remember what I said. If you double one side, what do you have to do to the other side? Double it as well. So you actually have to multiply this side by 2. You got it? Now watch. 2 divided by 2 becomes now. 2 divided by 2 is what? 1. So that's gone. So it's just x equals 44. Does that make sense? So to get rid of a fraction, you just need to do what? Multiply it by whatever it is, the number. Good? There's another way to do it. That last step, let me write it here. Now this is a fraction times a number here. All you need to do is, do you know how to cross multiply? Okay, yeah, this times that, up. So it's this one times this number up here. Okay, it gives you what? X equals 2 times 22, which is what? 44. Okay, so there's multiple ways of doing it. Okay, basically they're all the same thing though, right? Is that okay? This method here though, this method here only works when you have a single fraction and a single fraction or a number here. It doesn't work well if you have multiple things. Okay? All right, last question, and then you can start your homework. I know some of you don't like working in fractions, so try to get rid of the fraction right away. How do I get rid of the fraction? Is it divided by what? Divide by 3. How do I get it divided by 3 to get out of there? You what? Multiply by 3 on both sides. Alright, so again, you can do it different ways, but one way of doing it is getting rid of the fraction here by multiplying by 3 on this side, and you have to triple this side here as well then. Look over here, it's 3 divided by 3 now. 3 divided by 3 is 1, and 1 times 4 is just what? 4, right? So it's 4x is equal to 24. Now all I have to do is get rid of the 4 by dividing both sides by 4. And that gives me x equals to 6. It's good? All right.